something.
Yes.
Do you mind if I modify this a bit? Although it's a bit late to be fair.
You just need a talk.
Yeah, this so the date says January 27th rather than February 20th.
What is it? Sorry.
So on the first screen,
Yeah.
it says yeah, just need to modify this like February 24th. Yeah.
Ah, there you go. I can't view all the.
Oh, okay. So let's see if this works. Okay, perfect.
Sorry.
Hello, hello. Hello, everyone. Nice to see you all again this beautiful February. Hope you all had beautiful Valentine. It was a month of love. Anyways, forgive us for this. This meant to be February 24th. So just imagine using my using because you imagine it like February 24th. Anyways, welcome to another day at .NET Liverpool. As always, we're very happy to see everyone coming. Always excited to see people coming, obviously. Try to get more people in as well. And there'll be an exciting announcement. It's both exciting and non-exciting at the same time. So we've been here for quite a while. Next month, just like a heads up, next month we will be switching venues to a different venue. It's somewhere down by the Baltic markets, like a 8 minutes walk from here, like pretty close by. So it's is very accessible as well. But just like a heads up for next month, would be exciting to see everyone there as well. It's like a very nice venue also. Before we get started, first thing we want to do is shout out to our organizers. If you do not know much about the event, it's been going on for quite a few years now, and I would say 7, 8 odd years. It was started by Josh over there. He's been doing this through the COVID and now, as well as other supporters, including myself, Chris and Rafi, who's just joined us the last couple of months. Um, yeah, just shout out because it's all happening because of the nice little work everyone puts in, chipping away at it day by day. Next thing, group of people would like to shout out to our sponsors. The next set of people that make this happen every month, the S&A Academy. If you do not know much about them, let's see if I could go a bit further. So it's an organization that helps with education. They do basically government-funded courses for both your staff and people in your organization. This is all paid for and funded by the government. You do not need to pay extra. So basically, if you are interested in getting this set up in your company, you just have to reach out via PR code, QR, not PR code. Uh, yes, have to reach out via the QR code, or if you did fill it in the raffle draw form earlier, we would also reach out to you for this. Some other very important people would be, I do have to go forward and backwards a bit, guys. Hyperloop, if you look to the back, you'd see Alex over there. Alex manages Hyperloop. He's been sponsoring us for the longest time. He runs a recruitment company, both in Liverpool, across the UK, and quite recently in the US as well. So if you are looking for new positions, you're out in the market, Alex is the person to reach out to. The last and most important bit would be Backlist Ego Labs. I would say for people that have been coming here for quite a while now, we've been here for, I'll give it a couple of years now, and that's all thanks to Ego's Lab. And what they do is business support basically for anyone in the digital field, both towards like finance and banking, as well as some launch pads for startups. So if you are looking to build a business, do reach out to them. Also, they do have office spaces within this building and the next one, the one next door as well. So if you're looking to book office spaces during the week, please do reach out. Or if you did fill the QR form as well, the raffle form as well, they would reach out to you. Perfect. Last but not the least, the JetBrains. We are also sponsored by JetBrains. The raffle ticket has been going out. If you have not signed up to that, do reach out and we'll get that to you. So at the end of the talk, we do a raffle draw to give out one license for JetBrains. You could use it for any of their products. They've got like loads of products. So if JetBrains is your poison, do try to get on the raffle draw, and we'll do like a raffle draw. And one person gets that today. Something to note is this is being recorded. We don't usually get people's face, to be fair. Only the speaker does get shown in the videos. But if you do watch back the videos or you do not want to be shown in the videos, kindly reach out to myself or Josh and we'll try to edit you out in the final recording. And if I'll just hand it over to Andy, amazing.
Thank you. Hello, hi everyone. My name's Andy. I'm a recovering technical architect. So I'm going to talk about some patterns, hopefully. So hopefully the takeaways from the next kind of however long I talk about patterns and maps. The kind of 3 or 4 things I want you to kind of take away, and I'll explain what each of those things are. Got a lot of slides, so I will share the slides afterwards because I've got quite a bit of stuff to get through. So my background, I've been working in .NET software engineer for a long time, 20 years or so now. About 10 years ago, moved into a kind of a technical architect role, and then over the last few years, I've worked at Footasylum, Cinch, and then most recently I'm at Flipdish, which is kind of an Irish tech unicorn, and I'm also part of the kind of Team Topologies. If anyone read Team Topologies, the book, it's a good book. It's a good book anyway. But yeah, and we ended up being a case study at Footasylum, and then when we moved over to Cinch, the kind of the approach that we took ended up being one of the case studies for reInvent 2022. So yeah, talk a bit about kind of how we got to Las Vegas, if that makes sense. But it's not about me. This talk is about kind of these sorts of things that you tend to see happening. So has anyone been through this sort of situation where the people before you did a digital transformation, and then this happens, and the CTO's gone overnight, and then this time it's going to be different. We're going to do it properly this time. It's going to be a proper digital transformation. We bought the post-it notes this time. But it turns out to be kind of like Groundhog Day. You've not really solved the underlying problems. You've just masked it, and then it's that 18-month window of somebody new joins. They've got all the really good ideas. They realise there's loads of constraints. They change the constraints, and then they end up leaving, and it kind of falls over. So what do we do? What do we do about that? So I think, well, not me, but J.R.R. Tolkien started with a map. And so I've got 3 or 4 different types of maps that I want to kind of talk through, which I think really help to find out where you are, where you want to get to, and kind of chart a path. So I guess, is there any people who consider themselves to be like an engineering leader or a senior engineer or a tech lead or something like that? I know you definitely are, so you can't lie. But like, I think if you are in engineering at the moment, the thing that's super important is that you can illuminate the whole system of work, because AI is kind of like crumpled the beginning part of coding. And what's actually super important now is context. It's being able to turn the lights on, understand a system, and not just build anything, because you can build anything now, which is terrifying and brilliant at the same time. And I think I will talk about why constraints are good as well. One of the things that really helped us at Cinch was putting in place constraints around how teams worked, and that actually gave them a lot of freedom. I know it sounds a bit weird to say constraining freedom, but I'll explain what I mean by that. I think one of the most important things you can do if you're trying to get into like a leadership role, technical architect, or even if just aspirations to be a leader, is to figure out how to build the capability for teams to actually see and spot their own limitations. So maps help you do a lot of this stuff. Okay. Has anyone read The Goal before I go any further? Amazing book. If you haven't read The Goal, it sounds terrible. It's a business novel, which is just what you want to read at the end of a hard day. But it's a brilliant book, and the book is about a guy who ends up working at essentially like a car, a factory, and he's got like 60 days or 90 days whatever to turn it around, otherwise they're going to close it down. And he has a mentor who helps him to figure out where the constraints are in this system. It's like a business fable. Sounds terrible, brilliant book. But even better than the book, have you read Beyond the Goal? The Beyond the Goal is even better. And the reason why it's even better is it has this quote, which is the best quote I've ever seen in anything technical, which is technology can only bring a benefit if it diminishes a limitation. So the goal of tonight is you're going to hopefully take away some maps and some techniques so you can understand where the limitations are in your system, in your context, okay? Really good book. Definitely read it. Even though I've said it sounds terrible, it's fantastic. And it will teach you about the theory of constraints as well, which if you're not familiar with it, it changes how you see systems fundamentally. And I'll explain what I mean by that in a bit. Okay, so let's turn the big light on. That's a kind of a Bolton Northern joke. If anyone's Southern, you might not get that. So when I talk about maps, what I'm basically saying is visualizations, okay? You can visualize a system very easily. You can go up to a whiteboard and draw some boxes, but the ones that are really, really useful and the ones that have been like groundbreaking at some of the companies I've worked for, ones where you can understand position. of a map. You can understand distance, time is meaningful, okay? And it's fluid enough that it can evolve, okay? So I'm going to talk a little bit about maps and I'll explain exactly what I mean in case you're wondering why am I talking about maps so much at a .NET meetup. But the problem is the majority of the time when we talk about maps and we draw things at work, they're not maps, okay? We're going to draw our system. This is what, every 6, 12 months somebody comes along, usually somebody who's like a technical architect, so they'll just get on Miro and draw it out. And then they start off like this. They say, oh, there's the front end, there's the back end, and then you get loads of people in a room and you end up with something like this. Okay, that tends, has anyone got one of these in their company, one of these diagrams? And usually the problem is, if you've done it on the wall, it's even worse because it's a lot harder to move something you've drawn on the wall. And then what happens? They go and die in Miro. Or when you actually search for it in Miro, you look at the last time it was updated and it was like 4 or 5 years ago, and you think, is the system's probably changed since then? This map is probably useless now. And the 3 or 4 weeks spent building it, probably a waste of time. So what I want to do is go, if people haven't seen South Park, these are the underpants gnomes, okay? So they know they want to collect underpants, they're going to do something and it ends up in profit. So that's kind of what happens in a lot of companies. They don't really have a proper strategy. They just know we need to sell more of the thing, but how do we do that, okay? And I think the problem a lot of the time is most maps are created once, okay? You have that, you know, we're going to keep this up to date this time, and you never do, okay? They get increasingly wrong over time. I think this is like, it's like if you automate, I know it sounds daft, but if you automate your CI/CD pipeline at the very start of the process, you bake at that point in time your ignorance, because as the system evolves, you never normally go back and change it. Same with like once you start to draw something and make it, you know, put it on Miro, from there on it's getting wrong. When the system evolves, people start building on it, it diverts from reality quite easily. A lot of them don't have any strategy in there. I know that sounds a really boring thing to say. I'll talk about strategy. Usually there's lots of boxes and arrows, but there's no sense of movement. As if I take a database and move it to another part of a diagram, that doesn't mean anything, but it should. If I move something from one position in another, if I did that in chess, that would have an impact, right? If I did that on a mousetrap board, it would have an impact. So it should when I'm doing a technical diagram as well, right? And then, you can move boxes around, nothing changes. Okay, they're not maps. Okay, normally they're just terrible diagrams that we all do. Always we say we're going to do C4, and we've got several layers of C4, and then we get bored, or we start doing. If anyone done C4 diagrams, I know he probably has because we got talked to him about it years ago. But if you've ever done C4 diagrams, it's like a multi-layer kind of zoom in and zoom out of a system. You usually do the first couple of like layer 1, layer 2, and you go, oh, this is really complicated. Let's just not bother. But ultimately, the goal of what I want to get across to you in the next 40 minutes or however long I've got is situational awareness, because that's super key for anyone in any role. Understanding of our context, and context is even more important now because of AI. Like this is the important thing, context. The rest of it kind of does itself, but Cursor doesn't know your problems and it doesn't know your constraints. It just has a general view of the world. How to kind of evaluate options against reality. I'll talk a bit about that. How to make trade-offs, and how to reason about change before actually making the change. So diagrams and things that we can mess around with and see the impact of it. Okay. Also, get going. Like, well, the biggest takeaway from this is like go and start mapping some stuff out. I'm going to talk through 4 different types of maps, but all maps are wrong. I think there's a quote. I think Alan Box, I think it is. Like all maps are wrong because if you had a one-to-one map of Germany, it will be Germany, the size of Germany, you know. So every map you make of Germany is going to be wrong because it's not one-to-one, okay? So just get going, start mapping stuff tomorrow. Don't worry about it not being perfect because the goal is conversation, okay? So one of the things I really want you to take away as well is, does anyone work at an organization where it's difficult to kind of to talk about a system because the person who built it is like the founder, or you know the lead architect who's been there for 20 years is, you know, the system has a name, you know, we used to have one at Footasylum, but you know the kind of the person who's written it is very proud of that thing. It's always difficult and they get defensive, but if you can map something out and you talk about the map, and you know, if we move that database out from here, you know, and here's the map and here's how we draw it out, you're not challenging the person, you're challenging a map, and it's a lot easier. So, okay, what are the useful properties? And I will move away from maps. I'm obsessed with them in a minute. So good maps have time in them, okay? Good maps have maturity in them. Good maps show direction, and good maps show a capability as well, okay? So if you're not sure what I mean by these things, I want to explain. Okay, now's the time, now's the maps. Okay, so I want to talk about these 4 different types of maps, and these have been really super useful at Cinch, at Flipdish, I was at Prolific, we did a lot of kind of wildly mapping at one point in time. We were able to work out where our constraints were, and it unlocked a whole bunch of customers for us. Are people familiar with value stream mapping? First of all, people heard of value stream mapping? Good people, amazing. What about event storming? Cool. Team Topologies, a couple of people, and then wildly maps. Has anyone done wildly mapping? Has anyone, I know Ian's definitely done wildly mapping, but has anyone else done wildly mapping? So wildly mapping is the best one of the lot, and I'm going to save it to last like a pudding. Okay, so value stream mapping is essentially where does work get stuck? It's that simple. It's like the easiest map you can make, and it's super powerful. And you think, why have I never done this before? But it's basically a way to understand where waste is in a system and what's the lead time and the process time. And it's a really useful technique. Event storming, you're going to need a lot of orange post-it notes, and we spent a lot of money on post-it notes at Footasylum in the early days. And it helps you to understand from a business perspective what's happening in the past tense, and you can turn it into domain-driven design and all of that kind of stuff. Team topology is a really good way of mapping out your teams, and that sounds quite boring, but actually if you start to map out your teams, you can start to understand where the constraints are. If you've got 5 teams to do a release, for example, there's probably some problems there. You can start to map out the interactions between teams and actually mold your teams to the right shape. And then that influences the design of software. Because there's a concept called Conway's Law. If people are familiar with Conway's Law. If, for example, if you had 5 teams who all worked on a compiler, you've probably got a 5-step compiler because the shape of the team influences the design of the software. Okay. And then wildly mapping is about strategic landscape, which sounds really business talk, but it's absolutely brilliant. And one of the things that I think was super useful for us at Cinch and enabled us to kind of beat the competition. If anyone's familiar with Kazoo, and if anyone's got a car from Kazoo, sorry, your car warranty probably isn't valid anymore. But yeah, I can talk about why we were able to kind of undercut them through wildly mapping and what happened. So first of all, value stream mapping. So if you're not familiar with value stream mapping is basically mapping out a value stream, would you believe? And a value stream is basically a sequence of things that need to happen in a business, whether you're getting a coffee, getting on the train. There's a series of things between somebody wanting something and someone getting something. And that sounds really kind of, oh yeah, obviously. So on the left, you've got a need. Say, for example, I need to buy a new HDMI adapter for my laptop. I go on Amazon, that's my need. To realize the value, it has to arrive and be plugged into my laptop, but there's a whole bunch of steps that sits in an Amazon warehouse for ages. So there's loads of things in the middle, but if I work for the company that does all this stuff in the middle, how do I know how long these things take? Unless I map it out, okay? I need to go and see the process. So there's kind of, when we talk about value stream mapping, there's 2 different types, and I'll explain why these were so useful for us at Cinch. So I spent a couple of years at Cinch from 2021 to 2023 as the head of engineering, as we were kind of scaling from being on Kubernetes and Azure. They'd just moved from Kubernetes on Azure to serverless in AWS, and I kind of joined just as we were starting to get going and really scale up massively in kind of Manchester. If people were working in Manchester in like 2022, there's probably a recruiter from Cinch at some point that was asking if you wanted a job there, because we were called Pinch, because we stole everybody's engineers. So there's kind of 2 types of value streams. So there's operational value streams. So that's like me wanting a new laptop and going on Amazon. The steps for me to end up with a new laptop is that operational value stream. And then there's a developmental value stream. So this is as a team when you have your path to production, for example, or you have build, test, deploy. Those are development value stream steps. I want to deploy something, it is now in production in front of real customers. There's a bunch of steps in the middle, okay? So the way I want to kind of explain that, so an operational value stream, so I'm still in this from Team Topologies online course, it's a really good course, and some of the stuff that we did at Cinch and Footasylum's on there as well. That's a terrible plug, I don't make any money from it. So, but anyway, operational value stream. So if you assume it's an e-scooter company, this e-scooter company, you search for a scooter nearby, you scan a QR code, it unlocks a scooter, you ride to your destination, hopefully you don't fall off and have a head injury, you lock the scooter at the end, and then it charges the customer's account. That's an operational value stream. That's a business, okay? Then a development value stream, maybe one of the teams that maybe does the QR code part, that team needs to discover new API enhancements, plan the work, develop the work, ship the work, support the work. Yeah, there's a whole bunch of steps there, okay? And these are super useful, okay? Obviously, they're super useful. And they link together. So say, for example, we've got the product details team. That's part of the operational value stream, for example, in an e-commerce website. The payments team, they have a development value stream of maybe they have GitHub Actions, they deploy to Azure, they have tests, blah, 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 blah. that is probably like maybe the checkout page. Does that make sense so far? The relation between these two things. And what it ends up looking like is a bit like this. So for example, from an e-commerce website, the products page is version 1.60, and the team that works on that is going to push 1.7, for example. So you can see the kind of the relation between the two things. Very nice. Okay, probably thinking brilliant. Cool. How do I even find those things? So what's really useful, and this was one of the things we did at Cinch a lot, was actually go, what are we trying to achieve? When we have people in person together, or we go and say, okay, well, let's go and see the refurbishment of cars. So what happens if people aren't familiar? You go on WeBuyAnyCar.com. If you go on WeBuyAnyCar.com and trade in your car, it goes in one door and comes out the other on Cinch's website, all shiny because they're the same company, same parent company. So we go and see. So like if there's a team that worked on the putting stuff live on the website, there's a whole bunch of steps to refurbish a car. So our team that did that would go around and look and map out and say, oh, why does it take 2 minutes for that step? And then the car gets not QR code, what's the other thing? The RFID on the windscreen, and then it sits on a car park for a year, and then it gets scanned and it gets put on the website or whatever. So like our goal at Cinch a lot of time was like reduce the time it takes for a car to get on the website. It was our goal. And the way we did that is understanding, okay, what's the service where that's being delivered? To get a car on the website, there's probably 3 different teams. So we look at, okay, let's go and see how the car gets moved around. Let's map that out. Let's time it and understand where the constraints are. You end up with this kind of diagram. When you've mapped it out, you're essentially going, how long does it take for a thing to happen? And then how long does it take between that thing and the next thing? Okay, that sounds like you think, oh yeah, but it could be anything. It could be if you go into Starbucks, they take your order, they have to put a cup in the machine. It maybe takes 20 seconds to grind the beans, a minute to make the coffee, and then maybe 30 seconds to maybe scan the QR code. Okay. In between, it could take 6 minutes if that person is serving 20 people at once. So if you map out, it takes 3 minutes, but actually there's 87 minutes, maybe not for a coffee, but maybe for Cinch, maybe there's 87 minutes between the car being ready to go on the website and going on the website. And you can go, what? Why does it take 87 minutes? That's nuts. So our goal was always time. We'd walk around the warehouse, we'd walk around and see the cars and constantly timing it. We would have an iPad and we go, okay, why did it take 6 minutes? Okay, let's do it again, see the next car. But we do that all the way through. And you can do that in stores, you can do that all over the place. Got quite a few friends who work at Co-op. They're obsessed with how long it takes for somebody who wants to pick up an order in store. Because the people in the store, with Co-op in Manchester, you can go and using the website and kind of have crisps delivered to your door kind of thing, right? But somebody in the store has to hear there's a thing beeping that says, oh, I've got a new order, I need to go and pick and pack it. And they're obsessed with reducing the time because they want to basically have it so it's like 10 minutes from wanting crisps to getting crisps or whatever. But they map it out, they do a lot of this sort of stuff. But the other side of it, which I want to talk about, which is really, really useful, is not just mapping out the business, but mapping out how you deploy stuff. And this is what really changed a lot of how we worked at Cinch, and it was one of the main reasons why we ended up being a case study for AWS, because we were able to reduce the time it takes to get things from an idea to production in about 8 or 9 minutes. So through AWS serverless, we just collapsed the time as much as possible. Our goal was, I think, under an hour to deploy to live, and it ended up in about 8 minutes. And it was because we've mapped this out consistently. And every few weeks, we'd look at it and go, whoa, why is there an architecture review here? It's one little change. Can we put in place some heuristics or some automation, or do we need pull requests? We constantly shaved things off to reduce time. And then at every step, we kind of would delete steps where possible. Okay, so you're going to, hopefully, step 1, you do some value stream mapping, okay? And when you do that, you'll find there's loads of problems everywhere, right? And you go, oh God, we need to get rid of all these things. We've got constraints. But actually, the worst thing you can probably do is remove a constraint, okay? And I'll explain why. So I think there's a pattern here that I think I like to call it like deliberate bottlenecks. But when you go and map this stuff out, you'll figure out there's one part which is the slowest. Okay, there'll be one bit where maybe you've got a bunch of test suite of like, I don't know, automated tests, and it takes 10 minutes. You could just go in and remove those tests, right? But is that a good idea? So you have to really look at it and say, okay, well, when we figure out where the bottleneck is, we need to illuminate it and then accelerate it, okay? So the pattern's basically 2 steps. And we did loads of this at Flipdish, and done it at a few companies. So you basically go and figure out there's a constraint. The constraint is testing. Okay, we don't do anything with the constraint. We just know it's there now. Make it really obvious and say to everybody, why is it taking 20 minutes to run our automated test suite? And then pick one metric everyone can see every day. So you need to understand and map time. Create a constraint, stand up. Like we would run, we'd have these little mini stand-ups when if we knew the biggest constraint was maybe publishing cars to the website, as well as the team having a general stand-up. If there are 3 or 4 teams that we needed, the 3 or 4 teams will get together and say, it's currently 24 minutes, what can we do in our next cycle of work as a group? And it wasn't remove, don't put cars on the website. It was how can we accelerate that? Because actually every car went through the same process. But if you think about it, a car doesn't really change too much. If it's a Fiat 500, it has 4 wheels, 2 doors. There's not much variance there. So why do we have to have loads and loads of checks before it goes on the website? If we put one Fiat 500 on the website before, we can probably put another one on there. Okay, there's probably not that many checks that are needed because the pictures don't change too often. We normally have like 6 or 8 pictures or whatever. But you can start to measure it. Okay, how many times did the constraint wait? 0 is the only good answer. You want to reduce the time you want to kind of have an express lane where possible if we start removing stuff. And figure out what things don't actually need to wait. Does every single thing we do need to have a pull request? Do you need 4 environments? One of the things we ended up doing at Cinch was removing a bunch of environments because we couldn't understand, we couldn't explain when the CTO said, why have you got UAT? And it was like, you're supposed to have UAT. And it was like, well, do we need it? Because if we're able to release every 7 or 8 minutes, the test run really quickly, why don't we just have dev and live? And then we'll catch it in the pipeline. If we don't, we can deploy another version. Like, oh, just get rid of UAT then. But so, get express lanes. And there were some things that did need UAT, but not everything needs to go through UAT. So we worked out what's the quickest path to production and then install that kind of traffic light. And then, yeah, you'll join sort of new company and you'll go, let's just remove it. Just delete the old stack and we'll move to the new one. But actually the old stack was the one that makes you loads of money. So yeah, deliberate bottlenecks give you some control points. So when you've done value stream mapping, hopefully you'll not just remove a bunch of steps straight away, but you'll go, what's the time? Can we speed it up? And then the last result is kind of removing it. And then, yeah, what you'll start to do is I've talked a lot about time already, but what you'll start to do is go, how can measure? Once you start telling people to measure things, they'll have like 100 measures. Just pick a flow metric. How fast does value move through your system? Have one that's about flow, have one that's about rebuilding the right thing, like North Star. Are we influencing gross revenue or something, and then a sustainability metric? Can we keep doing this? Whether it's throughput of work or whatever, just limit the amount of kind of metrics that you have as a team, because once you start mapping and measuring everything, you can end up with like 50 measures, and yet you've not actually made any changes. So avoid over measuring, just measure on time to start off with. So that's kind of like step 1. But I suppose the real value in value stream mapping is to make it continuous. And this is what was really useful for us at Cinch. And we ended up putting in place this, we just got the DevOps checkpoint. And basically what we did is it's value stream mapping of our path to production. What we do is we'd look at the Dora website, and I don't know if you can still do this, but you used to be able to go on there and you'd be able to put in your Dora metrics. So like lead time, mean time to resolve, whatever, blah, 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 the 4 metrics, and it would come back and say, congratulations, you're elite, which is nice to know, I guess. But then it would say, okay, based on the fact that your team is elite, here are some things to focus on next. And it was more like organization or like whatever. There was always like 3 or 4 things that it told you could do. And when you go, okay, well, if working in small batches is the next constraint, we then look at our path to production, which is down here. We pick a few things and we do them. So it was like chaos days. We want to do that, flake end-to-end tests. And then we'd run it again in like 3 or 4 weeks. And we'd do it and do it and do it. And slowly but surely we reduce the time it takes. So what used to take 40 minutes became 20 minutes, 20 minutes became 10. But each step we just kind of had improvement work. And it all came from value stream mapping. Okay. And that was one of the main reasons that ended up being a case study, because we just collapsed the developmental value stream, if that makes sense. We'd collapsed all those different steps and we just had very simple architecture that could be deployed in under 10 minutes usually. And I think when I left Cinch, our cost for all of Cinch and AWS was $2,000 a month. So we'd gone from being on Kubernetes and being massively overcosted to actually we ended up being a case study, and it's like we've spent, I don't know, 24 grand a year, whatever it was. So yeah, very, very cheap. So, but it's a really good way to map out your value stream because it gives you purpose. We're going to map out our value stream and get better as a team of how we deliver software. Okay, you can do this as like an improvement charter. So basically, what's your current problem? What's the target? What's amazing that we're never going to reach? But what's the first step to being better? Could be testing, could be deployments, could be whatever. The improvement charter is one that I think Spotify use quite a lot. Government digital use it a lot. Co-op have a lot of these, but they'll just pick an improvement and they'll say, okay, currently we're crap at automated tests. We'll get better. Amazing would be the entire code base is automated, but we're probably never going to get there. But what's the top 3 things we can do? We'll go and do it in our next cycle of work. And we'd run this time and time again. So yeah, find an agreed measure of what good looks like. It could be the DORA metrics, it could be whatever's useful to you as a team of like a standard of good. And then look at where the team currently is, go and map out your path to production, value stream map it, understand the time it takes to, send comms out. So one of the things we wanted to get better at was sending comms to the rest of the business, because we were that quick. We'd forget sometimes that we had to let other people in the business know when we were deploying changes with new features, because somebody go, why is it suddenly different? It's like, oh, shit, we didn't tell you, we should have done. But yeah, so we decided to understand that our value stream was quite, there was a lot in there and there was stuff we can fix. Okay. Cool. And then push the improvements, have improvement work in every cycle of work. Okay. Make it regular, record the results and compare. And that's not comparing teams, it's comparing a team over time. So we could see if a team was getting better. So we'd run these improvements every month, every 2 months, these DevOps checkpoints. Really easy to do. And you will get better by doing these things just by illuminating your system of work. So 4 steps. Okay. Start with an agreed measure. Look at where the team currently is. Look at the current state. What can we change? Pick some things and do something about it. Okay. So value stream mapping is all about understand. Hopefully, do people get value stream mapping now? Is anyone going to go away and do it? Hopefully, there's lots of benefits to. Okay, so that was the first map, and that was the most boring one. The rest are fun, I promise you. So what we've done so far is identified a value stream, but actually we can do a lot more. We can take a value stream in our business and map out the events, map out the architecture, map out the teams, map out the domains. There's a whole bunch of stuff we can do. And that's event storming. So really useful map. I think a few people said they've done this. Yes, a couple of people. Event storming is brilliant. One of the best workshops you can do when you join a new company, because all you need is lots of orange sticky notes, okay? Okay, lots and lots of them, and I'll explain why. And you will need them. Take it from me. So I used to be at Footasylum with Ian there. Before Ian joined, I was really obsessed with event storming, because I've read the book by Alberto Brandolini. And when it came to the 2019 end of year blog wrap up, the one mention that I got in the entire thing wasn't even me, it was the CTO Paul, who was asked to justify £74 to the then finance director for post-it notes. £74 we spent on post-it notes, on orange post-it notes, okay? Which is a lot. So you've decided to spend £74 on post-it notes. Why have we got so many post-it notes? Well, the reason is event storming. Yay. So event storming is a really good book by Alberto Brandolini. It's a really, really fun book as well. He has loads of talks on YouTube. They're very, very sweary. So if you're going to put one on at work as like a lunch and learn, he's very Italian and swears a lot. It's brilliant. But it's essentially one of the best things you can do as a team. So we did it at Prolific, did it at Flipdish, we did it at Footasylum, did it at Cinch, loads. And you basically get a bunch of people, probably about 20 people. You get engineers, non-engineers. You want somebody from, if you've done some value stream mapping, you can start to understand all the different areas of your business, most likely. You want somebody who knows each part of that part of the business. So, somebody from finance. Always get someone from finance, because of the people that they're killjoys if you don't. But you need people who understand the business. And when you map, okay, that's the best thing you do. Go and do some mapping, and you work on the walls. And it's super easy to do, and it's really useful because Alberto Brandolini has this quote: it's developers' misunderstandings that are released into production, not the experts' knowledge. Because it's usually the engineers go, yeah, you want that? Okay, I'll go and do that. And then it's not what they actually wanted. You've just gone and, it's not what they want, it's what they need. So event storming, orange post-it notes, £74 worth if you can buy that many. We bought that many that Amazon was out of stock, which is we're really happy with that one. So it starts with one. So if you had a big pile of post notes here that are orange, tomorrow you could go to your area, your business. You do this on Miro if you want. We've done it virtually, we've done it in person. And you just want to start with a business event in the past tense. Pick one business event from your line of business. What's a good item added to basket? Okay. Put it on the wall, one post-it note. I mean, you say to everybody in the room, here's post-it notes, here's Sharpies. What's every business event before and every business event after? And what happens is you get loads of them. Okay, you want people to go absolutely nuts, and you want the wall to be full of post-it notes, because what you can do is you start with item added to basket, for example. You'll get ones after it, which are about orders being placed, payment being failed, users registered. You'll get all of these up on the wall when you start to order them in time. Okay, so from left to right, temporal ordering, I think it's called. So you want to basically be able to walk through, and you do this over about 2 hours. So you'll have somebody walking around taking post-it notes off when there's duplications, and you start to understand the full width of your business, the full kind of how money gets made, and it's all through events. So you end up with something like this. Let's say it's co-op's membership. Okay, you probably end up with a bunch of post notes that look a bit like this. You know, there's membership account created, loyalty points get added to the account, the points balance is updated, customer gets points get redeemed. In like an hour of loads of people, you've worked out a whole line of business on the wall, and for each of these, you can go, what system's that? When does that happen? Is that like for an event? You know, is it a service bus thing that happens here? Is the loyalty points system that our system? Is it a third party system? You can start to ask loads of really good questions, and you're mapping out over time. So it's a really useful technique, and it's really useful because once you've mapped everything out, you can start to figure out that there's kind of weird things start to happen, and you'll see the language change as you go across your map. What you'll find is that you'll find these little weird things that happen, like, well, the last thing is payment confirmed and the next thing's membership ID generated. Those are different systems probably. Oh, so that order, like payment being confirmed, ends up being like a pivotal event because everything changes after payment's been made, right? There's a whole bunch of things that happen, and you go, oh, there's a break there. And then you do more of it and you go, oh, on the left it's landing and activations, on the right it's a loyalty program. And then you go a bit mad and you do more of it. Before you know it, in like a couple of hours, you've got these weird like domains, like domain-driven design things start to appear, and you go, oh god, right, okay, that's fraud. It's different to payment processing, and we've got these people over here that pick in the warehouse, and we've got like a pricing engine, and then you can go, oh right, okay, which teams own those things? And before you know it, you've got domains, you've got teams. You can usually do this in about 3 or 4 hours, and it's great if you've just joined a company. You can find out so much about the system because that can't be wrong. If you've mapped out the business, you're in trouble if everyone's coming up with a different idea of what the business does. But if it's right, which it will be, you can start to do some really cool stuff. So we did loads of this at Cinch. And I think that was Natalie, I think. So she was the head of CRM, I think she was. But so she worked in like completely different parts of the business. We did a load of event storming, and we were able to work out exactly what the line of business. And this was one line of business. Cinch had about 12. But we were able to map it all out. And then every few months we'd go and do this, but every engineer understood deeply what they were building, why they were building it, what the events were after it, what were before it. And event storming has loads of different types of post-it notes. We just focused on the orange ones for the most part, but you can basically go from the event to who triggers the event. You can get into like policies of like, this event only happens if somebody's overdrawn or stuff like that. So you can start to codify business rules. It takes about 2 hours to do the main one, probably another hour or so to do the rest of them, but you can map out an entire system, line of business, company on the wall in a couple of hours, and it's amazing. So super useful to do. But then the benefit of that is you can then do some this is where the technical architect people go and start to wake up in the room. Because once we start to map stuff out, we can start to look at things like bounded context. People familiar with the term like bounded context and domains and stuff like that. So basically, you're probably going, oh, so it's basically like a domain tells you where value lives. Okay, it's a business, like a domain could be loyalty. You know, we figured out that there's a lot of post-it notes that say that's loyalty in that kind of like circle. The bounded context will be within that, the different individual areas where language starts to change. Okay, so if we've got co-op membership as a domain, we've mapped that out. We can probably start to understand that within that, there's a bunch of people who talk about member accounts and identity, people who talk about points and ledgers, people that talk about rewards and benefits and then redemption. Okay, so you draw a little box around there, and you probably go, that's probably a service. If that's probably a service, that's probably a service, this is probably a service, and that's probably a service, in which case we've probably got maybe 4 APIs, microservices, possibly, or at the very least maybe 4 controllers in an MVC monolith somewhere. But we've only spent a couple of hours on this, and we've probably got a fairly detailed idea of the system as it is and probably what it should be over time. What you can do is you can zoom into this sort of map as well. If you do it on Miro, you can then start to go, okay, we're going to modernize our loyalty. You can do a localized event storming just for loyalty and get into the idea of what system owns the data, what system pushes something out to Azure or AWS. You can get into lots of technical detail, but it's brilliant because all you're trying to understand is words. You're not doing anything technical. You're just going, oh, when we escalate something, we call it tier 2 escalation. Oh, they call them leads, but we call them users. And all you're doing is using like the English language really to like map out a system. So it's really interesting. Right? Although it doesn't sound it when it's somebody else doing it, I'll say that. But if you do it, it is very interesting, okay? Okay, so let's say, for example, within the checkout experience domain, there's 3 bounded contexts. There's checkout flow, order creation, and payment integration, okay? 3 bounded contexts within the domain of checkout, okay? So now we know that we've got checkout experience. Within it, our team now owns 3 different services: order creation, checkout flow, and payment integration. But our team owns quite a lot of stuff there. We've got a checkout team that's owning everything to do with checkouts, orders, payment service. Payments is kind of really complicated as well. Like if anyone's done anything to do with payment systems, you've got fraud, you've got know your customer, you've got all the stuff like Stripe brings in every few years, you've got EU regulations, you've got like data protection. Just doing payments is a lot. Never mind doing all the other stuff this team's trying to do. So when you've mapped this out and you understand what a team currently owns, you can go, Jesus, they really do own a lot of stuff, that team, and that's 4 or 5 people that own a whole line of business. And you can start to figure out we've probably got a lot of things going wrong. Because what tends to happen is one team is supposed to build all that stuff, deploy all that stuff, monitor all that stuff, support all that stuff, and improve every step. Okay, whole bunch of stuff that a team has to kind of do. And what ends up happening is it's a lot for teams. So this is where burnout happens. Are people familiar with the term cognitive load, by any chance? So cognitive load is basically like how much you can fit in your working memory as an individual, but then as a team, there's only so much you can really fit in your head until it becomes overwhelming and too much. You start to leak, parts of knowledge. You start to focus on the wrong things. You can't. You basically your brain gets a bit. Your brain turns into Homer Simpson, and it's difficult to actually really own stuff properly if the team owns too much stuff. But it's quite hard to measure. But it's really easy to event storm, and then from event storming, you can start to go, oh, that's a lot. That team owns a lot of stuff, okay? And then you get into things like Conway's Law, which I've already talked about. How you shape your teams directly influences the software that you build. If you have a back-end team, a front-end team, and a database team, you're probably going to end up with a 3-tier architecture just because that's where the handover is at the API or the data layer. So you really want to shape the org to get the architecture that you want. And a lot of this comes from event storming is the best way to start. So if somebody says we need to do a reorg or we want to go to like the Spotify model, start with event storming because you can get so much stuff just from event storming. It's a brilliant way to understand where you are, where you want to get to. And that leads me very neatly on to Team Topologies. So a few people maybe have read the book. So it came out in 2019. And it's basically a book all about team structures. And it talks about the fact that in organizations, no matter where you are, there's typically 4 different types of team and 3 different interaction modes between those teams. And you will probably find if you work in a team, you're one of these 4 team types. So there's 4 fundamental team types and 3 distinct interaction modes. And the reason why they've even bothered writing this book is because if you can identify which of those you are, there's a bunch of good practice and bad practice for each of those. What makes a good platform team from a bad one? If you're trying to have capabilities across a team, for example, where you want everyone to learn serverless and your team is historically on-prem, how are we going to plant that knowledge in the teams and how are we going to have the right APIs in the right place? It's a really good book. And it basically says the 4 different team types. You've got streamline teams, platform teams, enabling teams, and complicated subsystem teams. So if you work on a team that's part of the operational value stream, you're in a streamline team. If anyone works in like a team that's like the landing page team or the checkout team, one of those teams where your end users are a real life customer, a real world customer, most likely you're in a streamline team. Is anyone in a streamline team now? Can anyone go, oh, that's me? Hopefully a couple of people. Is anyone working at the platform space where your customers are usually other teams? So maybe you're the team that maintains the kind of the best practice and guardrails around AWS or Azure, the team that makes it easy for the teams to on-ramp onto the cloud, for example. Is anyone working that kind of platform or infra kind of team space? Okay. Or maybe, it's a team like that does the team that does payments, for example, like if it's a team that does like credit stuff, you normally have a platform so the teams don't have to learn everything about credit, they can just have an API that they can very easily. So Stripe's a good platform, I guess, for kind of credit. It abstracts a loads of stuff away, and if I want to take a payment, it's like 7 or 8 lines of code. It's fantastic. Got enabling teams. So if anyone's part of like a community practice or an architecture enabling team, like usually these are the kind of teams you see emerge during like a digital transformation. You know, the team that will be what good looks like, you know, the agile practitioners, the people that will go from team to team, trying to help teams speed up. And then the other one's like the complicated subsystem team. So some organizations will have these sorts of teams. Usually it's like if you've got like fraud or like really machine learning kind of like number crunching things happening, you'll normally have people, or like say for example, you do an augmented reality app, you'll have one team that probably does the core augmented reality, you know, real world model thing. And it's like the people that probably come from like a game design background and, you know, PhDs in maths. We put them in the corner. So we don't talk to them, just use an API, it's perfect. And then the other part of it is that there's 3 different types of interaction mode between teams. You're either going to have 2 teams where one facilitates something for another team. So that maybe one team is handing over an API to another team, and that team will work together for a couple of weeks and they'll facilitate a handover of knowledge. You may have 2 teams that are collaborating. Maybe you need 3 teams or 2 teams to work together over 6 weeks. And the goal is that you've built an API. And then at the end of that, one team owns the API and the other one calls it as a service. Maybe it's you've got a mobile app team and they need to expose a new endpoint from a legacy monolith. You'll have probably 2 teams that work together. Have anyone had that? We've had to wait for another team. They've given you a contract for an API or something. It's usually that sort of relationship. But ultimately, the goal that you want to get to in every organization is X as a service, where 2 teams or 3 teams, whoever it is, only communicate via APIs. They have loosely coupled kind of collaboration. Because if you do this for too long, or that for too long, you're never going to release software because Conway's law will stop you, or it'll make sure that you've got like multi-pass, you know, pipelines and all sorts of awful stuff. So again, mapping this stuff out is really useful because you can start to understand, God, we've been working with the platform team really closely for a year. Should we not have an API at this point in time so we can move really quick? So you can map this sort of stuff out. So going back to event storming for a second, if we map it out and we know that we've got delivery experiences, maybe a streamline team, the platform team is the DevX team, whatever. We want to get everyone in the company on board with Datadog. We like spending money. And maybe we've got a complicated subsystem team around payments. If we understand what all the different team shapes are, we can do this ourselves, right? We've event stormed and then we've gone, okay, well, basket and checkout, they have like 10 APIs from the platform team. Cool. But actually payments and risk spend all their time with delivery experience. Delivery experience are really bad at observability. So we're going to have to bring in like an enablement team to help them. That will take 6 weeks. So you can start to plan out the strategic moves, or at least understand how your organization's working and what good looks like. So, you know, if you're moving into like a CTO role or a head of engineering role, one of your goals is every team should move towards this. And if they're not, why not? And figure out what's slowing you down. And when you go into it, you do some event storming, you do some value stream mapping, you can see how all these different things start to link together. But these are just maps, okay? And I can move these boxes around. And it doesn't. I'm not ruining loads of people's lives. I'm saying, okay, well, actually, what happens if we didn't have an architecture modernization? Maybe if we just stayed in the monolith. That's a very expensive thing to do in the real world. But on paper, on Miro, it's very easy because I can go, okay, well, we'll maybe, you know, not spend 100 grand a year on Datadog and we'll roll it our own one or something. You know, you can start to make those decisions on paper and see what the outcome is. So everyone's still with me. Hopefully, a few people, the Keats is probably kicking at this point. People are starting to go, Jesus, not more maps. So at the minute, we've talked about the flow of value. We've understood the kind of constraints. We understand what what the best kind of interactions between teams looks like. What about strategy? So I think the best thing, whenever anyone mentions technical strategy, you know, like we're going to have a 5-year technical strategy. Goal 1 is situational awareness. Like you don't do anything before you look at a map usually. If you're in a new town or you're on holiday, for example, when you get out of the airport, you just start walking out of the airport. No, you usually like look at a map, or you'll go on Uber or something and you'll go, okay, I'm here. The taxis. You don't just start walking like Forrest Gump, you know. But a lot of times in organisations will go, oh, 9 out of 10 CTOs on LinkedIn walk in this direction. Let's also walk in this direction. You know, you kind of a lot of strategy isn't actually your strategy; it's someone else's on LinkedIn, and you end up with the underpants again. Again, if you haven't seen South Park, just ignore this slide. It's a cheap joke. But it brings me on to like the last of the kind of the 4 maps and the best one. They're very excited. Worldly mapping, a few people I think have said they're familiar with worldly mapping. It's brilliant. Anyone can do all this stuff as well. You don't need to be a technical architect to get post-it notes or map things out or get Miro's free. So there's loads of really good maps. Worldly mapping is probably the most important one. It was it changed how Cinch worked as a company. Used a few organizations since. It's a brilliant way to map out systems. And when anyone talks about strategy, you can go away tomorrow and you could do a world map of your business tomorrow if you want to, or your team, and it will probably be 10 times better than what someone else who hasn't done mapping. Gives you a strategic advantage. So worldly mapping is basically, people familiar with value chains? People heard of like value chains before. So it's basically, I'll just show you an example, it's easy. So every business has a value chain, whether you're aware of it or not. You've got a user, they have a need, there's a bunch of things that have to happen for that need to be made, and it's all the underlying things to meet that need, okay? On paper, I go onto Amazon's website, but behind the scenes, Amazon has hosting, warehouses, logistics, tracking, cars, all that sort of stuff. But I don't see it. Well, I see some of that, but a lot of it's just magic behind the scenes. But in order for me to get what I need all of that stuff to be true and to happen to be there. And you can map this out really, really easily, okay? And the reason why it's useful to do is because then you can start to understand where you want to spend your time and your effort, okay? When it comes to like, what's our 2-year strategy going to be, do a worldly map, because I'm going to show you how you can do some really cool stuff. So worldly mapping and all this stuff kind of comes from this chap. Does anyone know who this is? Sun Tzu. Yeah, so this was like 500 BC. He talked about landscape and climate and doctrine and leadership and purpose, okay? And then there's this guy, John Boyd, who's like a fighter pilot who came up with the OODA loop. People heard of the OODA loop. And it's basically, he figured out that if you are in a fight with another jet, you need to observe, orient yourself, decide and act, and then do that in a loop over and over again, like a system would. And keep doing it, keep looking, making a decision, acting, and then observe. Simon Wildey kind of came up with the map and said, okay, if I take a lot of this stuff and merge it together, it's strategy, and anyone can understand purpose and landscape and orient themselves and make a decision and act and repeat on it. So he came up with this, and it's like, what the hell is all this stuff? But basically, this is a strategy cycle, and I'm going to show you in the next 5-10 minutes how to build a strategy at a company. You can do it whatever you want. So always start with purpose, okay? Have an idea in mind. What is our goal? What's our goal as a company? What's the landscape look like? Because it's not just us usually, there's other companies. Say, for example, if we are a company that sells cat pictures on the internet, we're probably not the only company that sells cat pictures on the internet. What are the other companies look like? What are they doing? What's the climate? Is there EU regulation on cat pictures if we sell cat pictures in Europe, for example? And then you can kind of go, okay, once we understand where we are, we've got purpose, we understand the landscape, we understand the things that are closing in on us. Maybe there's going to be GDPR is a good example of like the climate, things change and it means you have to react. Then you need to have doctrine, you need to orient, you need to do something, and then you need to have leadership and actually decide and do stuff. And he talks about this strategy cycle as being a continuous thing that you do. But the main thing, so Sam Wardley's got loads of stuff about strategy, but Wardley mapping is the key one, okay? So Wardley mapping is basically saying, why does this matter? Why does this project matter? Like, that's a question you should ask. What resources, capabilities, constraints do we have right now? Do we understand what these things are? What are the market forces? What are technology trends and external pressures? Do we understand those? And can we, in your organization, can you answer these questions? And if you can't, how do you go about learning about them? Because these are really important. And then once we know that there's a problem, what principles and best practices are going to guide our decisions? Are we going to be event-driven architectures? Are we going to be TDD? Are we going to be pair programming? Are we going to have zero touch, nobody can log on to production? There's a whole bunch of things that we need to do, practices we need to put in place. And then what are the actions to achieve our purpose? What things are we going to do as leaders, for example? And the reason why I'm talking about Wardley mapping is because this doesn't matter where you are in an organization, everything's evolving all the time. Whatever you build today, in probably a year from now, has to evolve, and if it doesn't, somebody else is going to beat you to it because they're going to evolve their stuff to then beat you. So whatever you're building right now must evolve, and if it doesn't, you're probably going to, because everything else is evolving all the time. If you were building on ChatGPT or GPT 3 point whatever a year ago, and you stayed on that, and every other company has moved on to 5.2 or to Opus 4.6, they're probably doing better than you are in the AI space, because it's evolving. But if you don't evolve, problems are going to appear. So there's kind of different steps. So you can have this kind of thing where we've just discovered like that we can do something. Like maybe you're the first company that's doing augmented reality, and it's cost you loads of money. It's a custom rigged headset. And you go, wow, we've got augmented reality in like the 90s. You figured out how you can make it work for you. And then over time, the people start to solve it as well. You get competing things. You get S3 versus blob storage. And then it just works and nobody cares how. Nobody really cares about like, what's a good like virtual machines in Azure. Some people still use virtual machines. Some people use an app service. Some people using Azure Functions. Some people using container apps. Some people, they just deploy the code and they don't know what's happening. It could be on Kubernetes. I don't know. I don't want to know sort of situation. But it's evolving all the time. And systems evolve under pressure. So users want lower cost, high performance, and greater convenience. Okay, that's what people want. And over time, it becomes a utility like cloud. 20 years ago, you probably, maybe 25, you'd have a lot of stuff on-prem. Now, who's still on-prem? If you're on-prem, there's probably a very good reason for it. And if you're still on-prem and you don't have a very good reason for it, you should probably be in the cloud like everyone else is. And then when something gets commoditized, the price collapses. If you were on the AWS 15 years ago, the price of EC2 instance is massively different to serverless to Lambda. Cost has completely changed because more people use it, it's commoditized, all of that. And then there's no advantage. Once something becomes commoditized, there's no strategic advantage in custom building anymore. And I'll explain what I mean. I'm throwing loads of business things in, but I want to just give you a bit of a heads up before we start mapping. So this is a really good example of evolution. Okay, so on the left, we've got, I can't remember which one this is. So that is Edison's, it was a power plant. It was a test. I think it's Edison had built it. I can't remember, it might have been like Philadelphia. Does anyone know what this is? I know what it is anyway, but I can't see my presenter notes. But it's basically Edison, as a test, built a power plant in a house, okay? Completely custom built, but he was able to power a couple of streets with a power plant. Like that doesn't scale. And then in the 1920s, you had Ford's River Rouge power plant. So early cars, like 1920s, a factory would have its own power plant because electricity wasn't quite as commoditized as it is now. We had Edison versus Westinghouse, AC/DC, and then now it's kind of like magic. It just happens. I don't really know where the power's coming from. It might be solar, it might be wind, it could be nuclear, it could be coal, but that's evolved over time. And the price of Octopus Energy for me to charge my car is a lot cheaper than it would have been if I had a power plant in my house. So you can see how things evolve over time. It becomes a commodity. You can do the same with the computers. So ENAC, network computers, ARPANET, Dom Jolly, mobile phones. They evolved. The App Store, 4G to 5G, better cameras. We end up with like 4G and 5G in cars, self-driving cars. Drones. We use, this is terrible. We use Manna at Flipdish. It's a bit of a plug. So Manna's drone delivery of food. We do in Ireland, which is very cool. And then you're looking at probably like future, smart cities. But all that evolves over time, okay? So all of this that I'm talking about, evolution, is leading to worldly mapping, okay? So I'm going to talk about buying a car online. I don't know if I've mentioned, I used to work for a company called Cinch. So I'm going to do some worldly mapping with you now. And hopefully you take something useful away from this. So step one, add users and their needs. So hopefully you're still with me. So this is step one of a worldly map. We've got a customer and they want to buy a car online. Is everyone with me? Perfect. Okay, so for them, in order for them to buy a car online, there's a whole bunch of things that need to happen. We need to have search, evaluate a car, purchase a car, have the car be delivered, and then support if there's something wrong with the car, okay? So people still with me, okay? So there's a user, there's a need, and there's capabilities in order to meet that need, okay? The capabilities to deliver that need are behind the scenes. There's more stuff. There's storage, websites, cloud platforms, inventory, CRMs, there's compute. But I don't really see that as the customer. That's another layer down, okay? So then I create a little value chain. Say, okay, well, the customer wants to buy a car online. Search needs a website. Evaluating cars needs a website. In order to purchase, I need a website. Deliver, need a website. Support, needs a website. So we've got a little bit of a value chain. You can see the dependencies. Are people still with me at this point? Cool. Okay. And then behind the scenes, there's more stuff. Inventory, a pricing engine, maybe a CRM to hold our customers' information. And then we have some more stuff that's hidden away. That relies on the cloud. Could be AWS, could be Azure. Maybe we've got some like compute stuff in there. Maybe it's Lambda, maybe it's EC2, whatever. And then I've got some storage. And that's a value chain. And if you read it from the bottom up, we've got storage, which enables compute, which will be on cloud. Being on cloud enables pricing engines. A pricing engine is on the website. The website has search. The search enables somebody to buy a car online. So you can see that there's a listed user needs, and this is a value chain for a part of a business, okay? And you can map this out tomorrow if you wanted. But that isn't a map yet. So if you remember from the beginning, when I talked about maps, maps are about evolution, about time, about maturity. And this is where it becomes a Wardley map. This is a Wardley map, okay? So hopefully you're still with me. So basically, we've got our value chain, which I've not overlaid yet. And we've got these 4 different areas at the bottom. Genesis, custom build, product, and commodity. Okay, and what we do is we bring our value chain, and we spend about 20 seconds going, is that a commodity? Or is that unique to us? We just map it out and we say, okay, well, AWS is a commodity. Hopefully, like we're using the cloud. Compute is a commodity. Storage is a commodity. Pricing engine is custom. Okay, that's our thing. Our pricing engine is super important to us because it's probably our differentiator. Search, if we've got some kind of cool AI search, that's probably a differentiator because search is usually, the first thing that people see. If you can get a search for the right car very quickly, you've probably won the battle, which is what we did at Cinch. So you start to map this out, and then you start to apply. You can start to reason about it. So far, I don't know if you noticed, that's a lovely diagram. But so what? We've done some mapping, okay. But the really cool thing is what we can do now is understand where we should not waste time. Where do we need to compete with our competitors? Because now we understand the landscape. We can say who else is doing this. If there's lots of other companies doing cars online, do they have a really good pricing engine? Do they have loads of inventory? Are they building? Do we think they're building or buying their CRM? You'd hope for the most part companies are probably not building their own payment gateway. They probably use Stripe. But you can start to map out. But if your payment gateway is like a custom built thing where you hold all everybody's card details locally, you can probably go, that's probably not a good idea. Because are we trying to sell cars or are we trying to be Stripe? Because you can't be both. What's our business that we're in? And like I said, everything evolves. So what we do is we apply evolution. So we say where we are today is probably not where we're going to be tomorrow, hopefully. And Wildly Mapping on the website, it has this thing at the bottom. So the Genesis custom built product commodity, you can swap these out. So on the website, there's different versions of it. You can say, well, on the left, it's going to be things that are uncertain. On the right, it's something that's a known and accepted practice. So you can map out your engineering practices. And you could say on the left is the things that we're not too sure on, chaos days and chaos engineering, but on the right is like unit tests. It's standard. You're not going to make your own unit test framework. You're going to use any unit or whatever. You can go, is it understood on the stuff on the left and the stuff on the right? Everyone knows it inside out. Is it expensive to change, or is it just already cheap? So you can map out and change where you put your components, and it's just super useful because what it enables you to do is understand where you are, how things evolve, why a decision that somewhere else might fail here, what connects to what, and you can move components and changes the purpose. So if you were not listening for the last couple of minutes, we're going to play a little game. So this is the build or buy game, very exciting. Okay, so the blue dots, do we build the blue stuff or do we buy? Who thinks build?
Yes, because it's the product, no?
Who thinks buy? Who thinks build, first of all? The blue ones, a couple of people. Who thinks buy? Who doesn't know? Okay, perfect. Okay. So the exact same thing. Okay. The blue ones, do we build or do we build blue? Do we buy blue? Okay, perfect. Yellow, do we build yellow or do we buy? Do we build yellow? Yeah, and all we've done is we've applied evolution to it, and very easily, and you don't even know what this is. You don't even know what you're, I've not even put labels on there, but if I map it out on that right-hand side, you shouldn't be building it, you should be buying it. Somebody else's job. The right-hand side is Stripe. The right-hand side is AWS. The left-hand side is your custom-built stuff that's going to make you loads of money, okay? Sorry? A separate domain? Subdomains? Yes, yeah. And I'll talk about that in a second as well. So this guy's one step ahead, which is amazing. But you can literally start to understand, core supporting or generic domains as well. So that's another way of mapping this out. You can literally say, if it's core to us as a business, it should be, well, you'd map it probably slightly differently, but you might say the stuff on the right is the stuff that's absolutely core to us. Like, we're the only ones that are doing this. You might have some supporting stuff, but then might have some really generic things that everybody has to have. Okta, for example. But I wouldn't probably, I mean, technically, if you've used .NET over the last 15 years, you've kind of probably built your own identity server and gone, this is a terrible idea, should just pay for Okta. But anyway, the real goal is that you can start to map this out as a team. So on a practical example now, so let's say we've got a car website, you map it out, and you understand that at the moment, the stuff that's on the left-hand side is custom built, and the stuff on the right is the stuff that we build, the stuff that we rent or we pay for. But this is where strategy comes in, because we can say, well, actually, our strategy is we don't want to, we sell cars online, but we spend 90% of our time on a crusty old CRM for customer data, but we shouldn't really be doing that. Maybe, I mean, I don't know why anyone would pick Salesforce, but hey, here we are. But you might want to move to Salesforce because actually we just want to pay someone else, it's their problem, customer data. We don't want to mess around with GDPR, but that's not easy, because in the middle you can have inertia. Because actually, maybe you've got nobody in the business that knows Salesforce, or maybe it takes 6 months to procure Salesforce, or maybe it's a really difficult migration. But we've mapped it out. We mapped out the evolution of the service over time. We can understand what the problems are, and it enables us to do some really interesting stuff. We can understand the components. We can spot those inertia points. I spent a lot of time on this slide. And then we can start to really understand, what do we evolve? Because we've got a custom auth server where we have a team of people that have to, every time we want to bring on a new customer, we have to do a load of work. Or should we actually move to Auth0 when it's just like turnkey, you get Apple ID or whatever by default? Where's there's going to be pain? Like, say our new CTO comes in and says, we're going to be serverless in 2 years, because that's how a CTO sounds. But actually the problem with inertia is that everyone's an on-prem person, everyone's been at the company for 40 years. But no one knows AWS. You can't just move to AWS. There's a problem. And all this overlaps really neatly with DDD and Team Topologies. So yeah, you can map this sort of stuff out, and there's a really good talk by Suzanne Kaiser, Fast Flow Conference help organize, but she talks about core supporting in generic domains, and that's why the mapping is really useful. Yeah, so where are we? We've done some mapping. Here's another example of some maps. And we can overlay our teams. Going back to Team Topologies before, we can start to go, actually, our loyalty team does some work up here, membership experience team or up there. Hopefully your platform team is further down. They're kind of invisible to the end user further down the value chain. You can start to understand messaging. Is our messaging Twilio, or have we got our custom SMS? Does somebody have to type an SMS out, when you want to send it to customers? You can start to work out, because actually the stuff on the left should be the teams that are really doing experimental stuff. The teams on the right should be the stuff where it's either a platform or it's a team that's like, it's a well-known, Salesforce engineers, or you've got a bunch of people that work around Dynamics 365, an ERP team or something like that. You wouldn't have, these people will work in completely different ways to the people on the left, and that's fine. You don't need to have the same way of working all the way through. The team on the left may do 1 week's design sprint. The team on the right may just be lean and just use Kanban and just pull work and do lean and stuff like that. Team Topology is a really good way of identifying this sort of stuff. And there's loads of different things you can map. Has anyone read this book, The Value Flywheel Effect? Brilliant book. It's all about AWS strategy. It's all about Azure strategy. It's all about cloud modernization. It's got a load of Wardley maps in there. But one of the really good things is he doesn't map systems, he maps teams. So in the book he says if we looked at this, if we Wardley mapped our team and we've got best practice on the right-hand side, and we've got things that we're not very good at on the left-hand side, as a team member, I need trust, clarity, purpose, an environment to execute, and opinions are heard. Hopefully feedback is fine, but actually, do we have diverse group of people, or actually is it all just white blokes in the 40s? So you can kind of work out that's a problem if you've only got, if you've not got diversity in your teams, you're probably going to build the wrong thing for your end users, because your end users are probably diverse. But you can map that out and understand where you've got gaps. You can look at mapping out security, for example, and go, maybe we've got pen tests every 3 months. but nobody on the team knows threat modeling, nobody on the team understands, best practice, and we don't do any security training. We can map that out and go, oh, that's bad, we need to get better at this, because actually nobody in the company actually accepts that we need to do security training. So you can have a strategy around those sorts of things. Nearly at the end now, couple more slides to go. So we've mapped everything out, but that's just mapping, okay? We've not actually changed anything. So this is where it gets really interesting, where you can start to go and do some fun stuff. So on the website, there's Wardley mapping and there's Wardley's doctrine, okay? So Wardley's doctrine is universal patterns. Doesn't matter where you work, you can apply these patterns and they will work for your company. And that sounds like some sort of terrible salesperson, but it's really true. There's 4 phases to it. Stop self-destructive behavior, become context aware, be better for less, and continuously evolve. There's a whole bunch of patterns. I'm just going to quickly rattle through some of these because they are really useful. It doesn't matter where you work, use a common language, challenge assumptions, use appropriate methods, remove duplication and bias, focus on user needs, use a mechanism of learning. It doesn't matter where you work, these are good things to do. Know your users. You wouldn't go somewhere and say, I'm not speaking, users, who are they? They're the people that make your money. So step 1, if you join an organization, you can stop self-destructive behavior just by box ticking all these things if you're doing properly. That's simple. So you can map out your system and actually understand where should we do these things. Once you feel like you've hit all of these boxes, you can move on to being more context aware, be transparent, be more open, have a bias towards action, manage failure, manage inertia, think aptitude or an attitude, think small as in 2 pizza teams, distribute power in decision making. Anyone should and can do these in a company. It doesn't matter where you work, you could do these things. And if you can't, there's probably a constraint that you need to overcome by doing something like event storming or something else. And when you get more complex ones, better for less. So once your teams are working well, you want to be better for less. At Cinch, it was about reducing costs, reducing time to live, reducing an AWS bill. There's a bunch of steps here. Optimize flow, do better for less, seek the best people, best technology, and the best teams are the ones that have people who are juniors, seniors, diverse teams. All of those things will work universally, and understand, commit to a direction, but be adaptable on the path. These are really good advice, and the doctrine's brilliant, but these are just words on a page. But what you can do is go through each of these one by one. I'm going to skip and explain. So let's say we go, actually, we're going to pick 10 of these doctrine, overlap it on our Wardley map. And for each one, we're going to apply the doctrine, focus on user needs. We can say, well, when's the last time anyone actually spoke to a user? If we work at a supermarket, when's the last time our team went and understood if people want loyalty? When's the last time an engineer stood at the till and watched somebody put a transaction through? That's a doctrine. You can do that on day one. You will get better by doing that alone, okay? From at the co-op, for example. Listen to the ecosystem. Go and look at what Asda are doing if you work at co-op. Go look at what Tesco are doing. That will make you better just by doing that. Standardized practice. Align how APIs are exposed. You don't want 12 different ways of doing authentication. You don't want 12 different ways of documenting systems. You don't want 12 different observability tools. Go and ask what you've got. Use appropriate methods. Agile is great. Six Sigma is great. Waterfall is great, because it all depends on which context you're in. If you work in a team that's doing a ERP thing for a factory, you do not want agile. You don't want new experiments. If that goes down at 2 in the morning, the company goes down. What you want is staggered releases and a 6-week release window and all those kind of things. Actually, in that environment, it probably works. But you have to understand what's the right environment for each of these things. Focus on high situational awareness. Yeah, there's tons of them. Once you've done that, the final bit, and now you can go home, is the gameplay. So you've got doctrine, and then there's the next level when you can do some really horrible stuff here, which is great fun, because there's loads of different. It says, okay, you've mapped out your system. You could attack the ecosystem. You could say, well, are we going to open, let's say you've got a competitor who are doing the exact same thing you are. You could open source your one and ruin them. Maybe if you're able to open source your version of the thing, but still maintain a line of business, you could put your competitor out of business overnight. You probably wouldn't do that. Or you could patent everything and become patent trolls. You wouldn't probably do that, but you could. You could do that quite easily. But the one that's really interesting, I just wanted to leave you with, is this pattern. Everyone will have seen, if you're not, even if you haven't, has anyone seen innovate, leverage, and commoditize as a pattern? You will have seen this. It happens absolutely everywhere. And it's a pattern that once you start to see it and you map it out, you'll go, ah, I've done it again. So and a quick example, Kindle. So started out Amazon, looked at bookstores and went, we'll move that online, okay? We'll take the concept of a bookstore and we'll commoditize and create an online bookstore. We went, oh, we're selling books online. Let's create a Kindle and have digital books. People want that over time, that become commoditized. The Kindle ecosystem is standardized on, .mobi files. And then they went, oh, we've got distribution pack. Let's try audiobooks. And then you end up with these things where over time, once you have this, it unlocks high level stuff. Once you've got that, and you commoditize that, it unlocks high level stuff that becomes an experiment and then gets commoditized. People understand how that kind of zigzag works. That's a bit of a high level one, a really even easier one. So for example, if you were on Azure 15 years ago, what you had virtual machines and app service, I want to say, and then blob storage. What happens is Microsoft let you build on their system. They mine the metadata around everything that you're doing and take the best elements of that and then build a product on top, like serverless. They do it everywhere. Datadog do this all the time. OpenAI do this. Claude are doing it at the minute. They will let people build stuff and then they'll take the best things of what people are doing and they'll put entire areas out of business. Security scanning, they've just started doing that this week and they've probably killed off half of the companies that do SaaS. But a typical example is S3 in AWS. This pattern was used because they could see that people were building an S3. People didn't want to have to manage servers, so they went, okay, well, we can see there's lots of people are custom building things around endpoints and other bits. Let's create Lambda. We'll build it on top of S3, build it on top of Kubernetes, whatever, and then we'll leverage the next thing. Datadog are doing it a lot as well. Datadog have so much of your company's metadata, and they'll build the next thing that you need. Cloudflare are doing it. Cloudflare, edge traffic, they're now doing workers, they're doing databases. It's this whole thing around it. What does it unlock when you commoditize something? What about AI? I hear you say. I've not even talked about AI. AI's made building really, really cheap. What time are we on? When do we need to finish? Got a couple more slides. Are we good for time? Cool. So AI's made things really cheap. So you're probably looking at that Wardley map and you went, well, maybe I will custom build my CRM because I can build it in 10 minutes. But it's not made owning cheap. It's made building cheap. Owning is still really expensive. Because this is what you'll start to go, I could build that in a day on Claude. And you're probably right, you could build that in a day. You can build most. I built an iOS app with 2 lines of context with no code whatsoever to get some markdown files that I wanted to read offline. It took me about 20 minutes. But if I put it in the App Store and built an API and tried to sell it to the people, that would be quite expensive. So you can start saying, oh yeah, we're gonna build custom because we can. Yeah, the initial cost is probably quite high because you need to spend £200 on Claude code or whatever. Ongoing cost is really high and you own it. You've got no operational maturity on day one. Security patches are your problem. The 3M pages are your team. When you leave, knowledge what's out the door. So yeah, custom building is a really good idea, but actually you probably have to work out, if I generative AI, building custom is expensive, but if I generative AI, the initial cost is relatively low. But again, the ongoing cost is high because I still own it. I've got, again, no operational maturity in any of these stuff that I've vibe coded. Does it scale? Who knows? The security patch is still my problem, lots of problems if you have OpenClaw. 3M pages are my team. When I leave, it goes out the door. But build and rent, yeah, it costs more, but ongoing costs are low because I'm not having to run the service for Stripe, for example. The operational maturity, Datadog have like 20 years of production use for their software. It works. Security patches aren't my problem, for Stripe's problem. If payment goes down at 3 in the morning, it's not my SRE team necessarily. My team may get paid, but it's Stripe's team that have to go and fix something. And the service continues after I leave. So Wardley mapping allows you to actually work this out. You can say, okay, well, if we've got our current system, AI is going to help us here. AI is going to help us here. AI may tempt us in the middle, but on the right-hand side, we should just not do it. Don't do it. Don't build your own blob storage. So there's a whole bunch of stuff. So what you should end up with by Wardley mapping is you should be able to see the stuff on the right-hand side should be stable. The stuff on the left is going to be really super crowded at the minute because people can vibe code everything. And it's working out which of those do I want to commoditize, because as soon as I commoditize it, I can unlock something else on top. So AI is going to make everything a lot easier, but what you'll start to see, and you've probably already seen it as well, is companies are going, we don't need as many engineers now because we've got AI. Are people familiar with like the Jevons paradox? And it's basically, if anyone at work says we don't need any more engineers because we've got AI, they couldn't be more wrong in life. What's it called? Eric Schmidt, the old Google CTO, he's got a terrible idea about the future. So Jevons paradox, it's basically said, it was used to talk about coal. It says when steam engines came around, it made coal really efficient. And he's like, oh, we won't need as much coal. And he was like, no, we just end up with even, coal being efficient meant more people use coal. If you have AI, it's making code cheaper. We produce more code creates more systems create more integration services create more complexity requires better maps to navigate. We're going to need more people. So the minute you start using Claude Code, you're going to need more engineers because productivity is going to go through the roof. You're going to build a ton more stuff. Ton more stuff needs a ton more people to maintain. So like anytime your CTO says, can we replace these people with AI? Say, no, we probably need more people, and you'll start to see that in the next few. The more you do in AI, the more people you probably need because you can just do everything at the very start, but it becomes harder to commoditize. And back to one, just keep going. You'll see this time and time again. I think if anything, we're gonna have more engineers in a couple of years, not less, because we can do more. A really good quote by Linus Torvalds in 2000, talk is cheap, show me the code. I think in 2026, it's code is cheap, show me the talk. So it's completely inverted, and Wardley mapping allows you to understand that. So this is where you all add value. This is in the crowded space, and you only can really do that if you understand users' needs by doing things like Wardley mapping. We send to a values loft by doing things like value stream mapping. We draw boundaries between teams by doing like team topologies and understanding the team structures, and then deciding what to build next using things like Wardley mapping. Knowing and understanding what's commodity versus what's not. These are the things where the value is in 2026. Like code has been collapsed like the time it takes to build it. But what are you going to build? You understand what to build through things like the four maps we've talked about, okay? And we're going to have to make a bunch of trade-offs. So very, very final bit. So this is your goal, okay? When you go back to work, you don't have to be a technical architect. Doesn't matter if you do. But you're going to create constraints. Your goal is to reduce the cognitive load on teams by mapping, to avoid complexity by mapping, stop teams reinventing the basics by mapping, accelerate safe autonomy by mapping, encode lessons learned by doing maps. And there's a whole bunch of constraints you can apply. Like, anyone have like a golden path at their company, which is the way that we build it. Could be called golden path, could be called like your, what's the term? Golden path, the golden template, whatever you want to call it. There's a whole bunch of things you're going to do, and there's a whole bunch of things you're not going to do. Some useful constraints just to finish off with. A ThoughtWorks technology radar is a really good, if people are familiar with this. So every quarter, ThoughtWorks, who are a big consultancy, they map out what they think teams should adopt, trial, hold, and assess. Really, and it's whatever the latest technology is. But as a company, you could say, actually, we're not going to implement Kubernetes or whatever at the minute. You can start to set constraints, and it's a really good way of mapping out your systems because you can start to understand your own version of this. You could create a strategy, which is every team should adopt contract-driven tests, for example, but no team should be doing manual testing. You can start to put some constraints in place. At Cinch, we had the idea of kind of like our starter principles. So we basically said, day one, all teams can only communicate by event bridge. You're not allowed to talk to another team's APIs. You have to use events. Continuous delivery was a day one thing. So you had to be able to publish on with the first day that your team built something. The first thing they should do is get something to production that says, hello, I'm in production, and have a timestamp. And then you've at least proven you can get things to production, and you build on top of that. We'd have loads of constraints around. We prefer async event-driven systems bounded by. With no one size fits all doesn't work. We'd have sensible defaults. So our sensible defaults: AWS serverless for compute, DynamoDB RS3, TypeScript, don't tell anyone, but it's Microsoft, so it's fine. Python for data science and React for front end. And those are the things that teams have to do. Security was a day one constraint. These are just constraints that we put in place. But because we put these in place and we said you're only using TypeScript, teams could then do loads of autonomy because the front end people could learn back end easily, back end people could learn front end. When we started to do React Native stuff, the people that knew React could work on those code bases. We didn't share code, but we shared the engineers. There's a whole bunch of stuff that it unlocked by just, if we'd not put the constraints in place and every team could build in any language they wanted, it would be chaos, and nobody would be able to move team, or it'd slow them down. So those kind of constraints are the ones you want to put in place. Having guardrails, continuous delivery. Yeah, we had loads of these. GDS have tons of them. Constraints, they have the kind of the top 10 kind of like design standards. Cursor rules, a good idea of constraints. People using cursor, put it in cursor rules. Maybe don't use Tailwind because I think they're dead now. But you can put in place, always use always type, always use super base, always have our naming conventions, whatever SQL, always use strong typing. And, you can encode good practice in things like cursor rules. And finally, it's dangerous to go alone. You're probably going to go back to your organization. I want to do all of this stuff. I want to do Wardley mapping. Come on, let's Wardley map or whatever. Maybe you won't say it like that, but the first rule of Map Club is don't talk about Map Club. Don't lead with the name. Don't call it the thing. Whatever it is you're going to do, go and talk about it in. If you want to map something with finance, don't go to finance and say, we're going to do some event storming today. You're going to say, can we understand what happens when that event gets posted? And you can, here's some orange post-it notes, £74 worth, let's map it out on the wall. But, so you can start to do this, just don't call it the name. Wardley mapping. Never say Wardley mapping to people in the rest of the business. Just say we want to map our business value chain or whatever. You can put whatever title you want for it. And the next time you're struggling to find a path forward, ask them to show you the map. Even better, ask to draw one with you. So yeah, cool. Appreciate it took a lot of your time. Go do mapping. And if anyone wants the slide, I'm happy to share. Thank you.